Okay, so now we're upstairs at the computer, and you can see that when we do the Mathematica continued fraction for 1 plus 1 over square root of 10, it outputs 0, 3, and then 6 inside these braces.
That means repeating.
And that means repeating. And then when I do, oops, we were playing around with this. When I do from continued fraction, which is the reverse function, 0, 3, 6 repeating, it tells me that it's 1 over root 10. Okay? So the continued fraction for one of the cosines of our triangle is 0 plus 3 plus 6 repeating. And what was cosine of 72?
5 minus 1 over 4.
Square root of 5 minus 1 divided by 4, right? So here is the continued fraction.
Wait. Does it need the divided by symbol?
I suppose, if you want it to be right. Okay, so here we go. So what is that?
0, 3, and then repeating 4.
0, 3, and then a repeating 4.
Instead of a repeating 6.
Yeah. So it turns out they're continued fractions, although different, since they're different numbers.
They look pretty similar.
They do look pretty similar. So what do you think?
That's actually really neat.
Yeah. So I mentioned there was going to be a third triangle. That was a good approximation to both of these triangles. What do you think that triangle is going to be?
Maybe the continued fraction 0, 3 repeating 5.
Ah, very good. 0, 3 repeating 5. Turns out there was a secret third triangle that's very close to both of these. Because the first one, our 72-degree angled right triangle, the large angle's cosine is 0 plus 1 over 3 plus 1 over 4 plus 1 over 4. The one we found yesterday, the 1, 3 root 10 triangle, is 0, 3, 6.
Yeah.
So it might be interesting to see what 0, 3, 5 repeating is.
It's 1/14 times in parentheses -1 plus square root of 29.
Huh.
So minus 1 plus... So root 29 minus 1 over 14.
Yeah. So not quite as nice,
No.
Yeah.
but nonetheless.
It would be a good approximation.
Yeah, it's actually a pretty interesting approximation. And so if I do the numbers for these, just can you make sure I'm still on camera here? So for the first one, I get the cosine is 1 over square root of 10. For the second one, I get cosine is 1 over, actually it's square root of 5 minus 1 divided by 4. And for the third one, the cosine is -1 plus square root of 29
Divided by 14.
divided by 14. So let's take a look at these three numbers. 0.316, 228, 0.309017, and 0.313226.
So
These last two are really close.
well, this one's sort of in the middle between them.
Yeah, would we have expected this last one with the 3 repeating 5 to be in the middle?
Yeah,
Yeah.
Why?
because it's going
It's going to be larger than the one that's 3 repeating 4 and smaller than the one that's 3 repeating 6.
Yeah. And then if I do the, I can actually do instead of the number, I can do the arc cosine. Oh, actually, I probably have to do. Oh, let's see. Arc cosine. And it's going to tell me in radians, so I'll do it in 180 times this divided by pi, and I'll put that in and make that a number. So hopefully, I just want to run this first. Hopefully, the first number is close to 72.
So 1.56.
So now I'll do the same thing here. 180 times square root of 5 arc cosine square root of 5 minus 1 over 4 divided by pi. Make sure I didn't mess up. So 72 exactly, because we knew that was
Yeah.
exactly cosine of 72. And this other one is 180 times arc cosine.
It's 180, not 180.
Thanks for catching that. Divided by pi.
This one, 71.7462.
Yeah. So I didn't quite cut the distance in half. But it's still in between.
Pretty close.
Pretty close.
So you can imagine that triangle is going to be even more difficult to distinguish from our 7218 triangle. But the neat part isn't how close it is. It's that the continued fractions for our other ones were
Really similar.
really similar. Yeah, there was no reason that that should be true. They probably would have both started out with 0.3 just because of, that's what the
Yeah.
number were. But then we got a 4 repeating and then we got a 6 repeating. So it's pretty cool. So this number, square root of 5 minus 1 over 4 and 1 over root 10 don't look that different when you write them down, but when you write them as continued fractions, they're very similar. Very similar form of numbers. So it really depends how you look at numbers. Anyway, I thought this was actually kind of fun and a fun way to see. And by the way, if you wrote this number down, 1/14 square root of 29 minus 1, you wouldn't have thought that had any relationship to 1 over root 10 or root 5 minus 1 over 4, right?
Yeah.
But it turns out, if you look at it through continued fractions, it really is quite a similar number.
Yeah.
All right. Good job, guys. Good work.